Okay, these first two examples we're going to do here, they are using the same idea as we've been using. The numbers I'm going to give you are much larger though. Okay, so it's going to look a little bit differently. Or a little bit different. So the first one they give me is 625x to the 8th minus 256. And they want us to factor this completely. Okay. So when I look at that, I guess the first thing that caught my eye was the minus sign. There's only two things, and I see an 8. Okay? So my mind wanted to jump straight to difference of two cubes. Okay? But that doesn't work when the 8 is an exponent. Okay? Because x to the 8th is not a perfect cube. Okay? It is actually a perfect square. Okay? And we haven't went into this entirely yet, but if I were to square root x to the 8th, that would be the same thing as taking x to the 8th to the 1/2 power, which would actually be x to the 4th. So the square root of x to the 8th is x to the 4th. Okay? And we'll do this more later. Okay? This isn't like part of the lesson, just an explanation. That is a perfect square, not a perfect cube. Okay? No, it's 625x to the 8th. But x to the 8th is a perfect square. Okay? So if x to the 8th is a perfect square, what you should do is check and see if these are perfect squares. Because if they are perfect squares, then I have the difference of two squares. So it would be similar to x squared minus 4, just on a much larger scale. Okay? Is 625 a perfect square? Yeah. Yes, with what? Or what is the 25 is the perfect, or is the square root of 625? So my a would be 25. Or sorry, it'd be 25x to the 4th. What is the square root of 256? 15? 16, right? Is that what you said? I think it's 16. 225 would be 15. Okay. Okay. So I do have the difference of two squares here. So if I were to factor this, it would be what? X minus 2, x plus 2. Okay. What? What for? This is all made up over here. This is just an example of this on a smaller scale. Okay? This is this on a smaller scale. Just a refresher. Okay? So, over here, A was X, B was 2. Okay? So I need both the plus and the minus version of these two things. So when I take the difference of two squares, I'm going to have 25x to the 4th. Then what? Minus 16 and 25x to the 4th plus 16. Okay? Once I've factored it once, does that mean I'm automatically done? No. No, we need to go on and we need to check everything. Can I factor this? What is special about this? They're all perfect squares. So I could do the difference of two squares again, right? Okay. What would this factor to with the difference of two squares? Good. Okay. Is this anything special? No. Are they all perfect squares? Yes. Is there such thing as the sum of two squares, though? No. That is not anything that we have learned. So I leave this as 25x to the 4th plus 16. Has to be a subtraction sign for this to work. Okay. Is there such thing as the sum of two cubes? Yes. Yes. But there's not a sum of two squares. So is this fully factored now? Can this be factored? No. It could if that 5 was a perfect square, right? Okay, but it's not. Can this be factored? And we already said that could not be. Okay. Next one I have, again, these first two examples, I'm just giving you things on that are much larger numbers. This next one is 2x to the 13th power plus 10x to the 9th plus 8x to the 5th. What is the first thing we talked about yesterday that you want to try to do every single time? See if there's something you can take out of all of it. Is there? 2x to the 5th. They're all divisible by 2, and they all have at least an x to the 5th power. So I'm going to take out my 2x to the 5th. What would that change 2x to the 13th into? X to the 8th plus 5x to the 4th plus just 4, right? It'd be x to the 0, but you don't need to write that.
That's where I was going.
Okay. Now, we came across this a little bit yesterday. I don't remember how much we talked about it in this class specifically. Is it okay to factor something when, because we're so used to things being like x squared plus 5x plus 4 with a squared and an x to the first. Is it okay to factor something like this?
Yeah.
Yes. Now, here's the catch, though. It can't just be any random exponents. Okay, we can do x squared and x to the first. Yesterday, we did an x to the 4th and an x squared. Here, we're going to do an x to the 8th and an x to the 4th. What's the pattern here? They're double or half, depending on which way you look at it. Okay, that has to be true for this to work. Okay, they're not going to give you, and there's some other scenarios, okay, but they're not going to try to trick you here on these. Now, this one we could probably factor pretty easy. What multiplies to 4 adds to 5?
1 and 4.
1 and 4. So I would have x plus 1 and x plus 4. Okay, I use this, what's that? Don't forget what, sorry? Oh, yeah. Just pause on this for a second. But yeah, you're right. Because this is only x squared and x to the first. Okay? These are the same numbers, correct? Mm-hmm. So I'm still going to have the plus 1 and the plus 4. But what is going to change? Instead of an x, it's going to be x squared. So what do you suppose this one? It's going to be x to the 4th. Okay, so I'm going to have x to the 4th plus 1 times x to the 4th plus 4. And then just like Zach said, don't forget your 2x to the 5th out here.
Does that have to go on the right or the left side?
No, not technically. I would prefer you always, it can go anywhere. It can go in the middle if you wanted it to. It can go anywhere because it's all multiplication. But there's not a specific standard form, but if there were something I would call standard form, it would be to have that out in front.
And why don't you have to put them together?
You can. You just don't have to because it's not being added with anything. Does that make sense? Like if I were plugging in, I'd have to make sure to add this before I multiplied. Don't have to worry about it here. Okay. All right. So that's just a little bit more factoring like we did yesterday. Moving on to examples 5 and 6. This is changing what we're doing a little bit. Okay. They're talking about the factor theorem, and basically what the factor theorem is allowing us to do is allowing us to use synthetic division to factor polynomials. Okay? And I'll show you why in a second, why we might need that. Okay? But the first example I have for you, and keep in mind this first example would be possible just to factor a different way, much easier. But they're wanting to know, is x minus 3 a factor of x squared plus 6x minus 12? They want to know, is x minus 3 a factor of that function? Okay. And like I said, on this specific problem, it would probably be easiest just to factor it like we know how to do. Okay, but I'll show you an example in a little bit where that's not actually possible. Okay, so what we're going to do, first of all, if it's a factor, that would also mean it's a 0. Okay, we haven't done it for a while, but if I were to take this function that we did here and set it equal to 0 and say solve or find the zeros, when you got these groups at the end, what did we used to do with them? We'd set them equal to 0, right? Okay, and that would tell me what x is. Okay, so if it's a factor, then that means you can find the 0. Okay, so they're wanting to know, is x minus 3 a factor? Meaning, one of my zeros is positive 3. Right? Because I take x minus 3 equal to 0, and I get positive 3 when I solve that. So if x minus 3 is a factor, then x would have to be 3. Or one of the x's would have to be 3. Okay. We are going to use synthetic division to check this. So when I set up my synthetic division, I have a 1, a 6, and a negative 12. Okay, what goes out in front, though? Positive 3 or negative 3? Positive. Okay, because remember, we know x is 3. That's what goes here. It's like the evaluating questions from last section. But if they want x minus 3, then I need to do the opposite and do positive 3. Okay. So from here, what's going to happen is we're going to go through this synthetic division. If I get a 0 here for the remainder, then it's a factor. If I do not get a 0, then it did not come out evenly. It is not a factor. Okay? So what's my first step in synthetic division? Bring down the 1. 3 times 1 is 3. So it's not a factor. Okay? So if they want to know, is it a factor, you do your synthetic division, you don't get a 0, it's not a factor. Now, like I said, we could have checked that probably pretty easy earlier. What multiplies to negative 12 and adds to positive 6?
Nothing.
Nothing, right? Yeah. So how could x minus 3 be a factor if it's not factorable? Right? Okay. That one would have been easy to check or do differently. Damien, do you have a question?
I think
You can, but I'm going to show you in a second why you wouldn't want to waste your time doing that, and synthetic division will be much faster. Okay? This one's very easy. I get that. You could definitely do that. Okay? The next one they want to know, determine whether x plus 3 is a factor of 2x to the fourth plus 10x cubed plus 11x squared minus x plus 6. Okay, and could you plug in -3 here and solve it out? Yeah. Okay, I'll show you in a minute a scenario where you're going to have to be able to do synthetic division. Okay, if you can't do synthetic division, you won't be able to do what I'm leading us up to. Okay, so I'm going to set this up, and this specific question says, is x plus 3 a factor of this function? If so, factor completely. Okay. Well, right now, the reason I can't just go in and factor this, I can't group it because there's too many things, right? Yeah. And I can't factor it our easy way because there's too many things. So I can't just take this and factor it without synthetic division. So I'm going to plug in my numbers. I have a 2, 10, 11, -1, 6. Did I miss anything? No. And on the outside, I'm going to put a -3. And again, if this is a factor, I should get what here? 0. I should get 0. Okay, so let's breeze through this quick. I get 2, -6, 4, -12, -1, 3, 2. Okay, it's a factor, right? Meaning, I can factor this, or if I were to factor this, one of my groups would be x plus 3, right? If you would have just checked that by substituting in, you could have figured this out. But with synthetic division, it gives us the other polynomial after I've factored out the x plus 3. So this is our remainder. This is x to the 0. This is x to the first. X squared. X to the third. So after factoring out an x plus 3 out of this, I'm left with 2x cubed plus 4x squared minus x plus 2. And then you would have to go and check and see if you could factor this or not.
So that's why we need the synthetic division.
This is why you need the synthetic division, because without it, you could never even have got started on factoring this. Because there are some even numbers, but then there's 2 odd numbers. And there's 5 different things, so you couldn't have grouped it. So you have to have the synthetic division to be able to get through that problem. Okay? Are some of you supposed to be leaving right now? Okay. The rest of you who are not leaving yet, I'm going to do one more example like this, and then you can work on your assignment. Okay? So the last example I want to do is same directions. I want to know is x minus 2 a factor of f of x equals x to the fourth minus 2x cubed plus x minus 2. Okay. Before we set this up for synthetic division, I hope that we notice I'm missing something. What is it? X squared. What am I going to have to plug in?
0 squared.
0. Damien, sit up for me, please. Thank you. Okay. So when I plug this in, I'm going to have a, what goes first? 1, -2, 0, 1, -2. And on the outside goes a +2. Okay. First step, drop your 1.
1 times 2, 2, 0, times 2, 0, 0, times 2, 0, plus 1, times 2, 2, 0,
So it's a factor, right?
yes.
Okay. Now that one looks a little weird because we have a bunch of zeros in the middle. Okay. But just start here with, I know, since I got a remainder of 0, I know that this has to be a factor, correct?
Yes.
So I know I'm going to have x minus 2, and then I'm going to have something else. Okay. This would be x to the 0 power. This would be x to the first. This would be x to the second. This would be x to the third.
So
Okay.
it should be 1x to the third
So it's going to be x cubed
plus 1.
plus 0 plus 0 plus 1. Okay. Why am I not done yet? Is this a perfect cube?
Yeah.
Is this a perfect cube? 1 times 1 times 1 is 1, right? So what is this special called?
Sum of the cube.
Sum of 2 cubes. Okay.
Sum of the cube.
Why is that stupid?
It's a 1.
Yeah?
It's a 1.
What's 1 to the third power?
I know, but it's so stupid.
Fourth.
Because then we're just going to end up with like a million numbers and
No, we're not.
leave it nice like that.
No. It's going to be okay.
Look how nice.
Okay. So, first of all, A is x, B is 1. Okay. So when I have the sum of 2 cubes in my first set of parentheses, is it plus or minus?
Plus.
It's plus. What exactly is it going to be?
Plus
Plus
B.
1.
It's going to be x plus 1, which is a plus b, right? Times x squared minus
A times B, so x.
a times b, which is x,
Plus
plus b squared, which is 1. You about got that thing memorized, don't you, Damien? Good, and bring down that x minus 2. Okay. Double check. Make sure it's all factored. We're good here. We're good here. Is there anything that multiplies to 1 and adds to -1?
No. No. Solid no. Big no.
That adds to 0, though.
I really hope not.
Oh.
There's not. Yeah.
I wasn't paying attention to the part where you get the x plus 1 and then the x squared minus 0, or minus x. Did you do that again?
It's your sum of 2 cubes that we did yesterday. It's that pattern, special factor pattern we wrote down yesterday right here. Whoa. Apparently I did geometry on your guys' stuff. It's this right here. You have those notes from yesterday? It's the exact same thing. Except here, instead of x cubed plus 27, it was x cubed plus 1.
It looks so much better than it is right now.
And then it's not simplified all the way.
Okay? So take the rest of the class, work on your assignment. You should be able to finish most of it. There are a couple problems you're going to get to. You're going to be a little bit confused because I haven't showed you how to do them yet because we haven't done one example. We're going to do it first thing on Monday. Okay?